hey, I was at your talk and I have a lot of questions. If you reach out to me that way, I'd be happy to help any way I can. I have tried to make this as Java specific as I can. And the way that I wound up chasing this goal of like, how does Atlassian do DevOps and does DevOps matter? And I'm talking in Java 1, was to kind of look at some of the stuff we've said we do at Atlassian and try and filter that to the stuff that the folks who write Java for a living, deploy Java for a living, and run Java for a living do. Right? So as you may or may not know, Atlassian's been around for 16 years. Right? We started with a product called Jira. Jira, if you don't know the lineage, so there was a thing called Bugzilla back when your father was programming, probably. Right? It was very popular. And then, so a competing product was launched by the folks who founded Atlassian, and we wanted to call it Godzilla, right? Because that's better than Bugzilla. And it turns out Godzilla was copyrighted, so they tried to call it the Japanese version of Godzilla, just go Jira. Turns out that's copyrighted, so they just shortened it to Jira, right? So that's where Jira comes from for Atlassian. It has been around, this Jira thing has been around since, for 16 years now. I mean, I don't think anybody hasn't, if you're in the software development org, if you're at Java 1, the chances you've not been exposed to Jira are very tiny. I heard recently that every 5 years, the number of us writing software doubles, right? So I think you'd have to be a brand new graduate that somehow escaped getting hired by a company that uses Jira to not have actually been using it or forced to use it. But nevertheless, so how is it that 16 years later, a Java-centric application is still so damn popular? How does it still matter? How does it keep running? How did we take it and turn it into something that runs in the cloud? And the answer is, I would say in general, something we're going to talk about a little bit here, and something I'd like to talk about a lot with you in perpetuity. So if you want to keep chatting about that, I'd be happy to have that conversation. But that's where Atlassian comes from. You might know a bit about that. You might know more about it suddenly. I've been working for Atlassian only for about 6 months, actually. I'm pretty new to the company, but I've been in this business. I've been writing code for money and using Atlassian products or competing products since about 1997. So I have a certain point of view, and that point of view extends to before there was Java, and then there was Java, and now we have what we have, right? So how does it all fit together? That's kind of where I come from. Hopefully we'll talk about, I'll try to touch on this as much as possible, but it's like Java. But in general, everything I'm going to be talking about are things that folks who write Java for a living at Atlassian continue to do, have been doing, will be doing, have built 16 years of success in touching almost every single software developer along the way, right? All of that success has, in one way or form or another, informed the practices that I'm going to say, hey, maybe this will matter a bit. So let me, okay, I've wasted 4 minutes and 15 seconds. Hang on, let me go forward. It's on the clock. Oh, God. That's loud. So there's a lot to do, more than ever. In the past, it was the case that often, from a Java-centric standpoint, we would write an application, bottle it up into a WAR, an EAR file, deploy it into a single, WebSphere instance or WebLogic instance, or maybe a JBoss instance, and that was the app. And if we needed to scale up the app, the JBoss dudes would figure that out. They'd add more JBosses to that farm, and they'd have a WebSphere farm, they'd have WebLogic farms. We started finding ways to take lots of different farms and connect them and have multi-factor authentication talking over JEE or J2EE if you're older. And all these other, JX and JNAT and JY APIs that were so important to coordinating all of your stuff spread everywhere. It's funny that people talk about the idea of containerization, Docker, right? Hell, I was around for Corba, right? It used to be the case that we could build something deployed into, these were containers, and they would talk to each other. This is the 90s, right? And then, in the middle 2000s, we certainly had JEE. We had WebSphere. Boy, did I do most of that WebSphere. And, all of these ears, you would deploy an ear. For all intents and purposes, it was container. And it would describe all kinds of important things like, thou shalt only reach these databases, right? And if you try to reach other databases, you won't get there from here. And there are other things, too, about the amount of resources that can be consumed. So, in the past, we as enterprise developers using the Java, centric standards, we would describe what we wanted. Well, in this day and age, it's kind of expanded. It isn't simple anymore. We are amid a lot of other folks who are writing microservices that we must talk to. It used to be the case that we would talk on enterprise service bus to some of these other things. Now we talk just restfully at anything that has an open port that we can reach, and vice versa. And it's just like, it's kind of the same stuff, but now it's just exploding with complexity. And I can't guarantee that, it used to be SOAP, now it's REST. And then even if you're talking REST to someone, there's questions about, well, how do you authenticate with me? Are you putting headers? Are you getting a token? What is that relationship like? It's complex. And it gets worse when we start thinking about the security breaches and things. There's OAuth, for example, and multi-factor, or multi-party authentication that leads to how services will find each other. The complexity of things is getting more and more complicated than it used to be. It used to be, I just made a war, and I deployed it into Tomcat, and I tested it on my laptop, and then everything was cool again. That's not the case anymore. It's complicated. Even the HTML stuff, started getting split out, and we put on edge networks and CDNs and whatnot. It just moved on and on. And meanwhile, Ruby on Rails happened, came in with that sort of. Go is happening, Python is happening, Django, all these other things, and they have these assets, and it's just like super complicated. What does a complete picture look like? It isn't just that war file that we tested in Tomcat anymore, right? And it hasn't been for a long time. Also, there's all these weird hidden complexity things that are coming up. There's all this coupling. For example, I was reading the other day that Seattle's 911 went down for a few hours because some software developer was counting the number of 911 calls in an integer that maxed out. And when it maxed out, it stopped working. And so it turns out several different cities were all using this single source provider for 911 services, and they all stopped providing 911 at that point. All of the calls, before they got to a human, went to the magic thing that was counting first, and the counting thing stopped counting because they maxed out. So there are these weird dependencies between things that you won't necessarily notice anymore, and that is unacceptable in today's day and age. It's expected that these complex little phones we walk around with are going to work. When I want to go check my balance at Bank of America, it better damn well work, right? And if it doesn't, bad things. And so all of us are kind of, I don't know all of us, hopefully, I assume all of you guys look like you're up to good work, are having to face with some of these challenges of working with lots of, there's complexity. I didn't know that I was dependent upon some integer. Some guy wrote some other place. And this gets a lot weirder too. And there's no insight. Also, we're deploying into lots of different places. It used to be that we had one or two, or maybe a farm, or a cluster of WebSphere, to pick on that. Now we have EC2 instances that come and go, blue-green deployments. We could have as many EC2s as we want. I started working at a software startup in Mountain View about 4 years ago. When I started, we had a $3,000 a month bill and 0 customers. When I left 2 years later, we had more like, I think, it's called a dozen customers, and a $120,000 a month bill with AWS. Right, because we were just spinning things up. The development teams were spinning things up. They were trying out Redis clusters just for the fun of it, and then forgetting to turn them on. Right, and so there's just like, how are you tracking all this stuff? What is actually mattering, and what matters and what doesn't? So there's this idea that there are lots of different people who are involved in the value chain of delivering the software that we write. Certainly developers, there are these people who ran it, like in the past, this would be the WebSphere guys. And then, of course, there are all these customer service folks, or this legal team, the security team, the marketing team. There are these people who are not in IT necessarily, who are caring a lot about the software running and how people are either paying or not for it. Some people call this concept to cash. Right? This used to be like a supply chain term. Now it's becoming an IT term. Whereas, like, I wish that I could file a claim using my phone by taking a picture of my broken car, right? And then I get to do it. Right? It's a concept that a customer wants to pay money for. They'll pay some insurance company. The question is, like, how quickly then can we bring that to life? And so the chain of things that it takes in order to bring that to life is much larger than this anymore. And what's funny too, for those of you who've been around long enough, if you really are Java programmers, then you probably news for that. It is the case that the dev guys don't even talk to each other. So you'll have some folks like on Spring, and you'll have some folks who are just like anti-Spring, and you have folks who are just building their own crazy new solution to some middle tier. And when it brings, maybe some of you guys have found some aspect-oriented mushrooms, and you're alive with how fun it is to use aspect-oriented programming in your life. And these are all these different ways of going about tackling problems, and we're not even talking to each other. So how can we fix that? And so the answer, of course, or from the title you would presume that I'm going to talk about DevOps. I really see DevOps as something that is much broader than just ops and dev, but I'll set the hook for that real quick, and then we'll get further. From where did it come from standpoint, I can talk at length about this. In a nutshell, I would say though, if you don't already know, all of you should go home and immediately read the Phoenix Project. It's one of the funnest, most interesting and useful books I've read in my career over the past 16 years. Okay? I mean, I really love this book. I buy copies, I pass them out. I wish I had something to give to you guys. I really don't, or else I would. It's a fun read. And it's like, if you've been in software dev, if you've been in Java, you've probably been in software dev. If you've been in software dev, you know the cats and the stories and the problems that you're going to read about in this book. And it sets the story about the problem we all have isn't that we aren't working well, it's that we're not working well together, and we're not working on the same things together, right? And we're all connected, and we don't know it. We don't want to admit the fact that we're hyper-coupled, but we've got to solve for that. And so this DevOps thing, this lean software process comes out of it, actually, and then that becomes DevOps eventually. They wind up releasing a book called DevOps, and so they come up with these 3 ways inside of the book's systems thinking, improved thinking, constant experimentation. For those of you who are really old, you might know something about CMM or CMMI, and so I do. And so I thought about this stuff and said, hey, isn't it like knowing what you're doing, ultimately controlling what you're expecting, what you're doing, and then trying to improve it? Like, get good at knowing what you're doing, get better at controlling your expectation. Once you know what you're doing, you want to over-expect. And then, of course, you're always going to be chasing for new things that you can do. So that's DevOps. It isn't just your problem, it's everyone's problem. We need the folks in marketing to understand this very well. The folks in security need to understand this very well. It turns out that teams that figure out how to do this well perform very, very excitingly. My favorite term on this is the 430 times shorter lead times. So there's the State of DevOps report people who are awesome, the sober people. They run around and ask people how well you use these practices and turn them into value for yourself, and what practices you do and how well you do them. It's really fascinating. They do a great job. And my favorite thing, again, is that 430 time lead time. So that means if I envision this whole concept to cache I mentioned earlier, if I wish that a feature existed, or the customer wished that a feature existed, a bunch of customers wished that a feature existed in your products, how long would it take you to bring it to life? And there's a different kind of answer for Java guys often than there is for the Ruby on Rails guys, going back a few years. And so it doesn't need to be, but it just happens to be the case that the Java folks have been around longer, and so we have systems that had to be decorated. They had to be brought to the point where they could run very quickly. They have agility. Another thing that's been around a long time is Atlassian, and it happens to be the case that if you're on Atlassian, you're probably using DevOps too. There's a greater chance that those things come together. And so how can it be that Atlassian, 16 years old, applies itself to DevOps? Why do these things matter? How do they run together? And of course, Atlassian, throughout its lifetime, has been evolving the way it develops software, and it's been developing software on Java. Okay, we've been a Java shop. Now we're a polyglot shop. We have lots of different languages now, but our core products are very much Java products. So we do Jira, we do Confluence. So I'm going to refer back to this a few times. You've probably seen this in some of our marketing. It's kind of like ALM on steroids. The idea that we, not only build and run things, but also grab feedback, and we have a loop that's based around that. The slides will be available, and all this stuff is also available. There's a link later, which you should take a picture of. But don't stop taking pictures. Just let me know if I need it. Kind of my kids like me. All right, let's talk about how all of those products fit together. 10 guardrails. Here's the first one. Eat your own dog food. So the reason Atlassian for the past 16 years has been able to take our Java-centric shop and make it matter and adapt. Today's Jira is not your grandfather's Jira. Just to say it, we've changed that product a lot over the years. We've brought it to bear against the kinds of ways that we develop software and the kinds of softwares that we develop in a way that we didn't originally think about. We've been adaptive, and our products have been adaptive, and they're still in the market so great, and they still matter a lot. Why? Because we use them to do what we do. Okay, we are a software shop. It's convenient that Atlassian sells software because we write software. There's a nice little loop there, and so we do that, yeah. And so what is dogfooding? If you don't know, it's the whole idea of making sure that you're using your software, in the process of creating your software, essentially, or operating your business. And so what we're going to get to, God willing, is this next slide. So this loop figures into how we team. At Atlassian, this isn't exactly true for all teams, but most teams really do fall into this kind of pattern. We do still have separated, for the most part, we have separated dev teams and ops teams, which includes reliability engineers who react to things that go down. These are the folks who catch, the fury of something broken that our customers are excited about. They notice it first, right? So the guys over there on dev are always building new features and fixing things. These guys are always, first and foremost, making sure that stuff is running. And then when anything goes wrong, this loop happens and everyone comes together and we swarm to solve problems. So with the SREs, make sure things are running. And if they're not, they make sure we know. And when we find out, everyone gets involved in solving the problem. Also, the product managers, the marketing folks, the legal folks, the SecOps folks, they're all involved in this too. When something bad happens, we all get involved. All right, so that's the first thing that we do. All right, so that's why this matters, and how this works. So we think about planning, building, etc. And we'll go through each of these phases as quickly as possible. Why does this say to my laptop before sleep? Let's hope not. I wonder if I can beat. How long does everything this compliance? I'll hit close. Oops. So the first thing we want to talk about is how do we plan the work that we're going to do. It is the case that we monitor feedback from the market in lots of different ways, from how our users use our software. We have ways of getting telemetry and metrics about that. We also do things like scour social media so that we can get ratings. NPS is one of these things, where we look at Net Promoter Score, like, do you guys like our software or not? We monitor in all kinds of ways. We also have instances of Jira and Confluence and whatnot out there that are public that you can file a bug against Jira, and some other things. We'll talk about some of those things and how you can use them too. But we use those things and they inform a software development process where the product managers and some other folks get together and decide what we're going to work on. When it comes time for software developers to actually set about working on code, or for ops teams to go work on code, they're almost always either working in Scrum or Kanban software development processes. And I think I get to make them shake. All right, is that great? So this is what a Scrum board looks like in case you've forgotten or you don't know. It is the case that our software helps to track these things, but see the idea that things are moving through a discrete process, and we can see how many things remain to be kind of tested and how many of them are actually done. Scrum also works inside of those 2-week cycles or 3-week cycles, these iterations that are very popular. It's also the case that Kanban, the Kanban exists. It really does. Let's see if I can get that to show up. And the idea here is that we're not going to work inside of 2-week cycles, but every time a piece of work is completed, someone who is available, we just finished a piece of work, will go grab the next most important piece of work and get that done as well. And that's really nice because it kind of falls out of the software from a lean software development chain process. And so we see ourselves moving work items from left to right. This works very well from a dev and lean standpoint, but it has some problems with regard to making sure that the next piece of work that someone is going to work on is the most important piece of work. Also, it doesn't tackle unplanned work, which is one of those large problems. I think you guys are familiar with this, so I'll try and skip through it, but there's this idea that there are burn down charts where we have the amount of work that's left, and we have the amount of work that we're working on, hopefully increasing at some kind of velocity so that we get at the end of sprint, in this case, we get done. But what often happens, that's great if you can do that, what often happens is that unplanned work happens, or we didn't properly estimate the work, and then when we try to get through the work that remaining, something bad happens and we don't get there. One of the most important things that we can do to kind of figure out how to solve this problem is look at what's going on. And often it is the case that the people who are involved in delivering the process aren't talking, operating the process aren't talking to each other. I'm throwing things over walls, the silo problem we talked about before. Breaking these things down was critical to Atlassian. We did. And so we operate a more open process. If you ever go to Atlassian's headquarters, happy to give you a tour, let me know. Like here in San Francisco, you'll see that we are an incredibly open company. We use an internal wiki based on Confluence that will blow your minds. When I first started working at Atlassian, I can see almost every single decision has been made over the past 12 years. Exactly why we made it, why it was valuable, who decided, who was the decider, what fed into it. We have an incredibly open company, and that has given us the ability to kind of embrace this DevOps thing when it finally came along and got a name. So the second rule of Atlassian's DevOps is it's all about flow, and I believe this very, very firmly. It is about flow. And so one of the things that we had a problem with is that Scrum isn't really great at dealing with ad hoc problems that enter the queue of work. And Kanban doesn't give us repeatability with regard to what's going to happen every 2 weeks, because the higher up in the organization you go, the more they want to look at. And we're a public company now. They want to look at how are we tracking every quarter against what we said we were going to do. So it becomes this like, how do you mix those things together and you get Scrumban? And so most of the teams at our company are in fact using some form of the two of these things together, which allows us to have ordered backlogs. So that's the first thing. When we talk about planning, let me get to, here's how to turn it on. So what I'd like to point out is that there's this plan out there, right? So I just very, very quickly talked about how the stuff we want to do enters our concerns and how we plan to get it done. Now we're going to talk a bit more how we get it done. And that's a bit more interesting, I think, for this audience, at least for me. So let's talk about the next rule. The third one, the idea is that there's going to be one source of truth. One of the most fundamental things that we can do is make sure that all of us are working on the same thing. All of us are concerned with the same thing. All of us have a shared vision of what we're up to and what we're concerned about. And so to do that, we have at Atlassian a number of systems we use. They're based around the tools we sell, such as Jira and Confluence. But generally speaking, we try very hard to make sure that everything that someone is working on is being tracked inside of one of our tools. And we try very hard to make sure that it's tracked in a way that's not too painful to keep up to date. And we make sure that it's very easy for you to get to, for other people to get to, so you can find out what I'm up to as well. I can see what you're up to, I can see why it's valuable, why you made that decision to work on it. This single source of truth applies itself in lots of ways. One of the most important ways, of course, is where we store our code. I think from a software development standpoint, if you're not committing, if you're not writing code, if you're not trying code, if you're not testing code, you need to soon. Right? You can sit there and dwell on how you're going to write the code eventually for a while, but at some point you've got to sit down and try something and then noodle around. And so that's where things like this area here, the development panel, come in. And so I can very quickly with Jira do things like create an association between a thing that I've been told I need to work on or I've decided to work on and the source code branch where I am working on it. And so we see here that the system is creating a branch, a feature branch for me in Git. And then as I start committing against this branch, not only will the system know that I'm doing that, but it will also track whether or not I am continuously integrating cleanly, or even whether I'm continuously deploying cleanly. Right? So we have systems that do that too. But the point is, Jira, which has been around a long time, is now telling us not only the fact that Steven is checking in code, but that I have tested that code and even deployed it someplace that you can go try it out. Right? And the system does that for me. And it makes it visible so that everyone gets to it in the way that they're used to. By the way, this is an example of one of the user interfaces that's saying, not only am I working on a particular thing, but I have this many commits against it, and this is the latest build status, or the latest deploy status even. Right? So just in one place, other people are seeing what I'm up to. What's great about this too is if I'm a software developer, I don't have to go to Jira to give a status updates anymore. Right? I can stay on my command line, pulling and doing other things. So in order for that to work very effectively, I'm sorry, were you asking a question? No, okay. Okay, you're stretching. Branching for everything is kind of the way we've built a lot of the automated status. Now there are different ways that tooling can take advantage of watching your status and automatically picking up what you're up to. One of those popular ways is whenever we make commits, we mention the bug we're working on in the commit, right? Or if we're merging the PR, we mention it. We mention the Jira ticket. So this is one of the most fundamental things that we can be working on. The other thing is, and we'll talk about this more later, or actually I'll just show you a slide about later, there are loads of integrations because Jira's been around so long. There are hundreds and hundreds of other tools that plug into it that want to make friends with Jira's tickets and status so they can track the status as well, or update the status, or like take JUnit tests and update status in reaction to what the JUnit report XML file says. So there are Maven or whatever else. So there's a lot of integrations that are possible to kind of make it easy for something automatic to update status. In this case, we're talking about branching. Branches are really helpful from a Git standpoint, they're cheap. And so we're always chasing branches, and from that we go to this idea of continuous delivery by branch. Continuous delivery is important for these reasons. You probably know this already. We want to always be releasable. We want to do it often. And then this lets us do things like, even if I don't push a commit to prod, if I push it somewhere, I can send you a link to that place where that war file is alive. And you can go taste it. You can go see whether or not that's appropriate. I can even invite beta customers and early access customers to that thing. It used to be the case that we didn't do that in the Java world. It was very normal for that one Tomcat, that one WebSphere cluster to run the one ear or the one war file in its complicated configuration. Now, it's very normal, and we at Atlassian have that multivariate deployment where we have lots of versions live at the same time, some people taking it to some, and then we try very hard, we'll talk about this feature in a moment anyway. We also use like launch darkly and feature flags to make sure that when we launch an application, we can minimize the number of variants, but at the same time, hit lots of different configurations of users. So as a reminder, what continuous delivery looks like. I wind up on a feature branch. I make commits against that. That work is isolated, but it doesn't have to be untested. We have tools that can do that kind of thing. Other people are doing work as well, so that shows up in their commits against master. As I continue to work in an isolated way, I'm going to want to ultimately pick up those changes and plug my phone, plug in my laptop. So with those changes happening, I wish I had thought about plugging this in sooner. We have the issue of wanting to track all of these different things. It used to be in the past, as with having only one Tomcat, you could only have one variant running. Well now, with tools like the cloud, we can have lots of variants running at the same time. But then, that implies also that you can have lots of different work going on and lots of different feature branches. And if you guys use Jenkins, for example, if you've been using cruise control, originally, it may be the case that you had the one cruise control, and if you wanted to have several other variants of someone's work being built by cruise control or being built by Jenkins, you had to add extra configurations that an administrator would have to know how to perform. Or you have to take a configuration, dupe it, and point it to a different branch. These things are not working well. Let's see what's going on. It's coming back to life. So what we wound up doing at Atlassian is changing the tools so that they could support lots of work going on in these different ways, tracking the work, and then building the work, and then carrying that status back. So it becomes simple for us to have lots of variants of work going on at the same time. And because we're working inside of a single source of truth, it becomes simple for us to share that progress broadly. So we don't have to have, in the past it was difficult to want to do something like let every single one of you have your own branch that was actually running live. Today it becomes simple because we can aggregate where someone should go to find that specific status. And that's what allows us to move very, very quickly. It allows us to branch and then close branches very, very quickly. And it allows us to automatically detect that important status changes are happening. We do this at the branch level. Our products have been adjusted so that they also expose this capability. So by the way, here's an example of what a Jira workflow would look like. And what you can do is, you can, and we do, we set automation on every one of these transitions that trigger a status update. And the status updates don't have to be just the fact that you might have changed your, you might have committed or merged a PR. You can also plug into Crucible. One of the great things about being Java shops, by the way, is that a lot of you might be Crucible and Fishnet shops. And so there's a lot of integration that you can, a lot of triggers that you can derive. And again, this allows us to very quickly, each of us be working on features, but at the same time have global visibility. And also, it promotes the idea that we don't get too far ahead of ourselves. I can check in often, I can merge often, and we can stay closer together that way. So for that to happen, we want to be building on every push. And we have tools that do that, Bitbucket Pipelines and Bamboo. Again, these products exist not, I'm here saying we have these products that can go use. What I really want to be saying is we use these products. Okay, the reason these products exist is because we needed them. Our Java shops needed them. And now I'm telling you about how we use them. But it is also the case that you can use them too. So from a Bitbucket pipeline standpoint, this is how that looks. The idea is it's a Git repository. We're checking code in and out, opening PRs. One of the things that you can do is to turn on the pipelines feature. And basically, at this point, we don't need build agents anymore. It kind of gets in, you might think of it as something that Jenkins might do for you instead. I'll show you a bit about how that works and one of the other things that we figured out along the way. But what's nice is with the integration, with build integration, with continuous integration turned on, we can see that commits are either good or bad right here inside of our tool, which is super essential. We move very, very quickly. We're always working on lots of different things, and we need to know that the builds are clean or not. That's one of the most important things. The second most important, another most important thing, if you will, is that people are working. I can see the work that is occurring, and I can see whether it's clean or not. They can too. What's nice also is that whenever you click on any of this work, you wind up seeing a screen that takes you directly to, like if there was a build failure, you'll be taken to where the build failure is. This happens to be not Java related, this is NPM. But it works for Java as well, for Maven, for Gradle, for example. So that's one of the nice things about these things is when we go to build your code, or when Bitbucket goes to build the code of the user, it not only notices where things broke, it stores those pointers so that when you go to find out what went wrong, you don't have to search through logs to get there. Part of the reason we can build code at all is because we store configuration with it. So that looks like this. There's generally a YAML file at the root of a given repository, and it says a few things that are super important, like how to build your software. In this case, again, I have the node slides of it. But so you can see we run an install. Maven would have worked as well. Maven test, Maven package, or what there, Maven build, whatever you want. And one of the most important things to realize is that this is just a text file that is stored with my source code. So any given version of my application has a version of this configuration stored with it. They move around together, and this makes the ops guys' lives a lot easier too, in a couple of ways, because I could turn this into a container and ship a container to them. There's ways that we do that. But then also I can do things like I can just work with them to make sure that the configuration looks correctly. They can see it. It's out in the open, and it's carried around with the source code. It's all stored in a single repository, so that goes back to that single source of truth, right? And because it's all stored in one repository, when the ops guys need to change this configuration, I can see it because I'm a software developer working in that repository. Or if I'm somewhere else in the organization, I can see that because I look at Jira through its dashboards, and I can see that there's been movement. I can see that the ops guys are working with the dev guys to hone in on and keep the best configurations alive.
Can you show, please, your production pipeline?
So the question that I just got is, can I show my production pipeline?
Yes.
I can't show the production pipeline on a screen this large in front of this many people. I might be able to show off some of those things to you more privately, or if you hang around, maybe I can show you some of the things that we actually do. But it's a great question. It's like, okay, so I'm talking about like a simple, YAML file. I can assure you that our production pipelines look very different than this. Furthermore, just for what it's worth, you can see there's just steps here. Like whenever we have a pipeline that's going off, this is a default pipeline. We also have lots of other things like our non-default pipelines that are, they're based on regex patterns. So if you have a branch that is named in a certain way, we run different commands. So for example, if you make a commit, if you're in a branch and you make a pull request, or we pull request something from one branch to another branch that is named after QA2 or QA heavy, we'll run a different QA battery against that commit than we would have been landing in other branches. So we have very complicated.
Are you using Gitflow?
Are we using Gitflow? We do essentially use Gitflow, but also with release branches. So there's in a lot of our cases, we have a question is like, are we using Gitflow? And so yeah, we're using Gitflow ++, right? because we're adding certain named branches for production environments or for controlled environments. So when I do a pull request into a branch that's named after a performance test environment, then a performance test environment would get spun up, and we would do a heavy multi-hour performance test. Whereas the other builds would be much quicker because they would omit, something like a performance test. And so the pipeline uses, in this case, our pipelines feature uses regex to detect whether or not it should be doing something like that based on the branch that you're changing. So it's pretty straightforward, easy to understand, everyone can see it. It's versioned, and this is so important. I guess everyone knows that you should be versioning the bash scripts and the scripts that you use to deploy, and you should be using scripts to deploy, or you should be using automation. Maybe using Chef or Puppet, version that stuff. Yeah, so that's what this looks like. Use the YAML file. One more thing that it says, and I'll point this out, is that we use Docker. So when our pipelines go to operate, we don't spin up build agents on existing servers. We use Docker. Everything goes into a Docker image, and we run a Docker image that's been tuned for that purpose, whatever that might be.
Jenkins uses not the same syntaxes, so you are using this. Who is actually executed this YAML file?
Who is executing this YAML file? That's a great question. It leads to the next slide. You are asking all the right questions. So all of the things that execute this YAML file live inside of essentially the Kubernetes and Docker farm. So in our case, with the Bitbucket Pipelines feature, which you could use too, and I recommend that you do, the first thing we did was we chose Docker as the thing that replaces build agents. Right? So you say that this is the image that runs, that has Maven installed and JDK 8 or whatever you need, and the other configuration that is proper for building and probably running the unit tests of your software. That goes into a particular build environment that you've created a Docker image for. We chose Docker because of a few reasons. I think I have a few here. It's technology agnostic. This is most important. There's a registry, right? So if any of you guys create the perfect, build environment for your company, you can put that into a public repository, essentially, that can still be protected by using certain credentials and things, and make that available to our build apparatus. The other side of this is that there are thousands and thousands of existing Docker environments in these images that are probably appropriate. So maybe you have something that needs Redis, or you have something that needs a particular database in order for you to be able to build and test your software. Chances are you can find those things and you can kind of Lego them together, if that's a noun or a verb. And so we chose Docker for that reason too. Finally, the thing I'm going to get to is this. Kubernetes uses Docker. And so it's the case that whenever any of our builds goes to execute, we spin it up inside of an isolated Kubernetes hierarchy that prevents the tenants from talking to each other, right? And so this allows every single commit to run a build if we wish. And again, we control this based off of regex that's inside of that YAML file. And so, that one-off build doesn't need to happen anymore. We run them all if we want. And so, not only is this great from we get to run everything, we're running inside of a single controlled environment, so we know exactly what the cost is going to be, and we can scale that up when we need to, and we can kind of keep it exactly where we want it to be. This is something that we needed. Atlassian demanded this capability so that we could run fast with our Java development, and so we developed it, and then we turned it into a product as well. By the way, it is the case more and more often, and you should be doing this, that we as software developers are shipping containers ourselves. Right, so we don't just want to run in Docker, we want to actually build the Docker component and hand it off to ops or whoever's going to run. So it is the case that we've had to, because we were doing this, we had to make changes to Kubernetes and Docker, and we did this in concert with other people, so that we could run Docker inside of Docker inside of Docker, so that we could generate these images, turn them into golden repository assets, and then run them. So back to this picture of the branch where I'm doing all my work on a separate branch. I'm now at the point where I want to try and deliver it. This works out very well for us because we have a mechanism to run all of the tests. We have a mechanism to even run the thing that we want to deliver. And that allows us to do things like go test it. Oh, seventh rule, we have 20 minutes, 19 minutes left, guys. Maybe less than that. Oh, we have a lot less than that.
5 minutes.
We have 5 minutes, that's like 19. Round down. So there's this idea, we do have a number of analysis tools in our life. We do things like static analysis. Whenever code reviews occur, we want to capture the fact that it did occur. We do that with pull requests now. We did it in the past before pull requests existed with Crucible and Fisheye into Subversion branches and whatnot. So that was an issue, but we faced it back then. So when people caught up and said, "Hey, pull requests are a thing," we're like, "Hey, that's just like someone requesting you use Crucible to look at some code." So that was a straightforward ask, and so we have mechanisms to embrace that and lift it, both in terms of Bitbucket, but also Fisheye and Crucible, as I mentioned before. So not only are those commits happening, are those pull requests happening, but we can also guarantee that at least 2 other humans looked at a particular commit. That was something that was very important to Atlassian. Now that we're a public company and we run in the cloud as a service, we have like SOX compliance and a lot of other compliance problems that we have to face up to, and we do that through some very controlled mechanisms that embrace having not just a naive deployment of Git, but something that's actually meant for enterprises to use. And we know about this because we do it. Again, Atlassian does DevOps the Atlassian way because we needed to, we needed these things. So here's a pull request, and we're showing how people are accepting it. It's a pretty straightforward affair. We can also see how many builds it took, how many approvals are remaining. If we needed 3 approvals before we can move to prod, then we can know that it needs to happen. And we can also see that the builds are running cleanly or not. So when you go to review a pull request, you can kind of see exactly what's going on. This leads to a very fast cycle time. Remember, I told you, why is DevOps important? And there was these statistics. You can develop, you move 46 times faster, and 460 times faster at lead time or cycle time. This is how we do it. We have a lot of automation. We automate not just running your code for continuous integration and testing, but we also do it for delivery. And I think the most important thing is we do it from a status standpoint so that everyone involved can be looking at when something goes wrong. And when something goes wrong, we all get involved to figure out why it's wrong. Right? When something is broken, we all sit together and we figure out what happened. We don't just wait for you to solve that problem alone. We show up in force to say, what is it that we did wrong together? And so we all get smarter a lot quicker. So, the 8th rule, automate everything. I think I've covered this in one form or another. We also do things to integrate with stuff like Puppet and Datadog. Analytics is more important than ever. I mentioned the idea that we accumulate feedback about how our customers feel about our software, how well it's running. All of that is turned into automation that we can use to trigger the need for some feature to be made better, to optimize something, or to detect that something's going wrong. Whenever something does go wrong, for example, whenever something is broken, we ask ourselves, is there something about our Puppet, our Datadog, our analytics package that could have detected this sooner? And that turns into a couple things. It turns into a formal review process where we decide that there are analytics we need to use that we haven't before. And then we also turn that into work that someone needs to go do in a Scrum-bound iteration. And we talk about that and track these things, as well as once an outage has occurred, for example, a lot of beautiful automation leaps into place so that the operations folks and the developer folks who are working on an outage are seeing the same thing at the same time. And I can talk at length about how that works at Atlassian. So tests are awesome, but prod is truth. We deploy almost everything that we change. We do it almost all through Launch Starkly. We use feature flags super heavily. A lot of folks are, if you use any of our as-a-service products, you'll be exposed to new features depending upon kind of cohorts and experiment groups. We use this very heavily. Again, these are not just features that, these are features that Java guys can be using, Java folks. These aren't just limited to kind of the newer architectures for software delivery. And that leads to success metrics, and we can finally tell what's really going on, and so that leads to feedback and what we're doing. 10th rule is really that shipping since the beginning. I guess this is kind of like, to wrap it up, the most important thing is that the software we write isn't just so that it will test well and deploy safely and run correctly, it's so that our customers will be happy. And so we have a lot of mechanisms that grab feedback about how our software is running, whether our customers are happy. We put that in front of the developers, we put it in front of the legal folks, we put it in front of the marketing folks. There's constantly automation occurring that lets us tell whether or not the software is as designed, is as desired, is as a customer would be willing to pay for it, right? As a business, we're concerned about that. So we kind of reinforce this in two ways. We dog food, we use the stuff we're selling you because we are a software shop ourselves. But then we pay attention to whether or not that software is successful, whether it's scratching in a tree, guys, whether there's a problem or not. We can tell when it doesn't work for us, and often we can tell when it doesn't work for you because we have ways of knowing. If you use one of our asset service products, it's very obvious. Or if you tweet negatively about us, it's very obvious. We pay attention to those things too. Please don't do that. And there's more. For what it's worth, our products also expose things like portals so that you can very quickly erect a site where other people could, your customers could come and file tickets and they show up in a service queue. We have things that do that because we needed that. And that all builds in Palantir as well. We have things that point that back into work queues so we see who is doing what needs to turn into other work. In case you want to tell your customers, like we do, that something is broken, we have a mechanism for that, status page IO. There's all kinds of beautiful things going on with how status pages work to inform customers that a particular component may be degraded. Like maybe the login component is working fine, but the file upload component isn't. We have mechanisms that test for these individual components being faulty and then share that status with customers in a discreet way. We needed that, and we saw it as something you can take advantage of too. This all fell out of us being a Java shop that needed to build software, and it landed in the hands of people who themselves were Java shops and needed to write software. All of this stuff proven is how we do what we do. All right, I want to skip over the feedback slides, which I covered already. I mean, it's pretty obvious. I mentioned that we collect feedback from a lot of people, from many places. Whenever we discover something is going on, we post Jira tickets about it internally. We also build Confluence pages where we mull over these things. And by and large, that's it, guys. That is my deck. I mentioned the fact that we plug in lots of other software. For what it's worth, there's a lot more than just this. And I'm going to try and leave it with that right there.
Can you show your links? You said you had a slide.
Oh, yeah, I do have a slide with the links, and so I can't leave it there. I have to leave it here. And let me push forward to the next slide after you're all done, so you can take a picture of the contact information for me. And oh, you guys are great. One more. And there we go. So that's me again. I am Stephen Henderson. S.T. Henderson at Atlassian.com. And if you want to pursue more conversation with me about this, I would appreciate it.